Talk of building a base on the moon has been around for years now, but many perhaps still question what the point is in doing so. After all, as we found out in another recent video, there arguably was little reason to go to the moon in the first place in the late 60s and early 70s, except to win the space race and prove that we could. But now we seemingly have another space race on our hands regardless, to get back to the moon and this time stay there. The likes of Russia and China have announced their intentions toward a moon base, while NASA's Artemis program seeks to do the same. And the wider international effort includes the space agencies of Japan, Canada, the UK, Australia, and more. The most often stated reasons for going to the moon this time around include that it could take space research to an all-new realm, with ground telescopes on the moon, for example, offering a far better and wider view of the rest of the universe. The moon is also invariably billed as though it's a practice ground for Mars, too, with future missions to the Red Planet increasingly on everyone's radar. And with this in mind, from a practical point of view, the moon could also undoubtedly function as a fantastic launch pad in the future. Getting objects into orbit from Earth is hard because of the energy required to overcome gravity and break away from the planet. But launching rockets from the moon requires about 30 times less energy, meaning that if we could ever get the payloads there first, we could achieve cheaper, easier, and more efficient space travel. But of course, if we really want to set up a long-term or permanent human presence on the moon, we're going to have to learn to live off the land that it provides, for what's called in situ resource utilization. And let's be real, it's taken us thousands of years to really master this even here on Earth. And in many ways, we still aren't using even our own planet to its full potential or efficiency. The moon, by comparison, is hostile to life from the outset. And while we perhaps could make it work simply by shipping supplies from Earth, there are a number of issues with that strategy, including cost. The goal of current research, then, is to find ways to create new but sustainable environments on the lunar surface, or perhaps underground. And recently, scientists performed a world first by growing plant life in lunar soil, otherwise known as the regolith or moon dust. Breakthroughs are then already taking place. More important than even food, however, is being able to breathe. In whichever way you look at it, we're going to need a lot of oxygen to sustain human life on the moon. So where's it going to come from? As it turns out, and according to the most up-to-date research, there's actually plenty that's already there. And again, it has to do with the soil. Soil on the moon is different to soil on Earth. It's more of a mix of debris rather than soil as we'd imagine it. It's rock fragments and splintered leftovers from asteroid or meteorite collisions millennia ago. Moon soil is also constantly exposed to cosmic radiation since there's no atmosphere to protect it, which has an impact too. And yet still, incredibly, this soil, the lunar regolith, is actually around 45% oxygen in its composition, according to NASA, ESA, and all leading groups, which is a massive amount. And while the numbers have been crunched differently by various studies and sources, it amounts to there being more than enough oxygen present for any one person to survive, even within just a few square feet of the lunar surface. At the top end of the scale, it's been variously reported that theoretically, there's enough soil and oxygen total on the moon to provide for 8 billion people, close to the current world population, and ultimately not just for a couple of years either, but for hundreds, thousands, perhaps even hundreds of thousands of years, depending on how deep into the moon we dig. Suffice to say, this is some pretty good news, not least because oxygen has more potential uses than simply allowing us to breathe. It's also vital in fuel, which means that if an effective enough strategy were implemented, soil extraction could truly be a game changer for our space travel ambitions. Why then aren't we already tapping the moon for all it's worth? The main problem is that the oxygen that's there, trapped as it is in dust, isn't in gaseous form. If it were, it would drift away into space. Instead, it's contained in oxidized solid materials like silica, iron, and aluminum. On the face of it, this is no bother. Scientists do already know how to extract oxygen from these and can do so easily on Earth. But, unsurprisingly, it is also quite a bit more difficult to run the same processes on materials from the moon. To separate out all of the constituent parts and isolate the oxygen in lunar soil, we need to produce enough energy, a lot of energy, to break the individual molecules apart. And creating that amount of energy on the moon isn't simple. In fact, working out how to do so has long been a goal for scientists, who have actually long known that there is oxygen on the moon, if only we could get to it. On Earth, we employ a process called electrolysis, generally to separate metal from oxygen, because metal is more valuable to us here. But it would be the reverse situation on the moon. The oxygen byproduct is what we'd be most wanting to harvest. Only to do so, we'd need all sorts of heavy tech on site, which isn't really physically or financially feasible right now. So, are there other methods that might be used instead? In theory, yes. One is that we go the hydrogen reduction route, wherein we heat up lunar soil and then expose it to hydrogen, which acts as a reducing agent and produces water vapor. That water vapor is then put through a lighter version of electrolysis that might be more manageable. This method has been widely researched, too, with some experiments run using genuine soil samples from the Apollo missions. Experiments like these have helped researchers to glean other bits of information as well over the years. For example, it's been found that out of volcanic glass, one particular part of debris that makes up lunar soil, we can generate more oxygen than from any of the other soil materials. It's also been shown that oxygen percent yield is apparently related to how much iron is present in any one sample, with more iron generally meaning more oxygen to harvest. Of course, it's not as though the soil is the only potential source of oxygen on the moon either. There are proposals that we could just as well use basic electrolysis on the water ice around the lunar polar regions, at least in the beginning, before we need to siphon it from the very ground below our feet. And we know that moon mission planners are already extremely keen to develop a surefire way to extract water from the moon, for obvious reasons, but also because the hydrogen and oxygen present in the water could also be used to make rocket fuel. And the European Space Agency has already taken steps to get such an extraction process started, preparing the In Situ Resource Utilization Demonstration mission to show the potential routes forward. Meanwhile, researchers in China have reportedly developed a method that's being described as extraterrestrial photosynthesis, involving a solar-powered process also designed to turn water into oxygen. It would appear as though there is more than one way to go about it. But for now, simply knowing that there is oxygen there in any form is exciting. If we can learn to break down the basic components of lunar soil, we should then have a reliable source of life's most crucial element, which will help us grow food, make water, create fuel, build shelter, and most importantly, breathe. And that's why there's enough oxygen on the moon for 8 billion people.